For this part of today's lesson, we are going to be taking a deeper look at even and odd functions. I will show you today how to find whether a function is even, odd, or neither, both algebraically and graphically. So if you look here, I have the equations for when we can tell something's even or odd algebraically. So when you plug in a negative x, if you end up with your original function out, that means this is even. If we plug in a negative x and end up with the opposite of our function, that means it is odd. So we are going to take a look at a couple of these. So the first one will be f of x equals x squared. So to start, I'm going to plug in a negative x. So that means I would have negative x squared. Now, if I do negative x times negative x, I end up with a positive x squared. So if you look, my original function here is equal to when I plug in a negative x. So that tells me this is even. Even, okay? If I were to type this graph into Desmos, it's going to look something like this. That's what our x squareds look like. So I can tell just by looking at this graph that it is even because my arrows or my end behavior is going in the same direction. That's one way, but you also must have your function be symmetrical about the y-axis. So you can see here that this is the y-axis and it is the line of symmetry for my graph. So that tells me it's also even. So it must be symmetrical on the y. Okay, symmetrical on the y-axis. So let's look at another example that is an odd function. So we are going to do f of x equals x cubed. So I'm going to plug in my negative x. And now negative x times negative x would give me a positive x squared, but times another negative x gives me negative x cubed. So now you can see when you look at these two, they are opposite. Over here, they were the same. So same means even, opposite tells me it is odd. Now again, I'm going to type this into Desmos and draw a rough sketch of what this graph looks like. It's going to look something like this. Okay. And if I look at this, one way I can tell it's odd, my arrows are going in opposite directions. So my ends are in opposite directions. And this one has rotational symmetry about the x-axis. So again, it's got to intersect with our x-axis. So we have rotational that rotational symmetry, and we say it's 180 degrees about the origin. So that's telling me if I were to rotate this 180 degrees this way, and then this half 180 degrees this way, I would end up with the same graph. So that's how I can tell that it is an odd function, because it goes about the origin and I could rotate it. So that is a couple examples of even and odd. I do think it's helpful to look at an example of what neither would be. So when this doesn't work at all. So let me go to my next page here and we can look at that. So an example that would be neither would be our equation f of x equals x plus 5 squared. Okay, this one's going to take a little bit more work when I plug in my f of negative x. I'm going to do a quick box to multiply this out and see what I'm working with. So if I multiply this one out, I'm going to end up with x squared plus 10x plus 25. And then I'm going to do a box for this one to make sure I don't miss anything. So I have negative x plus 5 times negative x plus 5. So negative x times negative x gives me a positive x squared. And multiply these, I get a negative 5x, negative 5x, and a positive 25. So I end up with x squared minus 10x plus 25. So if I look at my signs here, these are the same. This is the opposite, and this is the same. So for this to be an even function, we would have had to end up with the exact same thing of x squared plus 10x plus 25. So we would have had to have same, same, same on our signs. So notice this is a positive, then their opposite, positive, negative, positive. So even, they would have been exactly the same. If it was odd, it would have had to be negative x squared minus 10x minus 25. So all of my signs would have had to been opposite. So when you do this, just because there's an opposite here, that doesn't make it odd. We have to have opposites in every position. So this function here of our x plus 5 squared is neither. Neither. Okay, and let's look at this on a graph. So if I would type this into Desmos, get a rough sketch. Okay, and I know that this is an x squared, but plus 5 is going to move me to the 5 to the negative direction. So my graph would look something kind of like this. So it meets the first criteria for an even function. The arrows are going in the same direction. However, its line of symmetry does not fall on the y-axis. So because its line of symmetry is not on the x-axis, that also tells us that it's neither. So the problem here is that it is not symmetrical about the y. So this makes my graph neither. Now for the next part below, you are going to have to draw some quick sketches on your paper of 8 different graphs. Now that might seem like a lot, but they can just be quick sketches like mine. They don't need to be perfectly incremented out or anything like that, just quick sketches. And then you are going to be determining, based on those 8 graphs, which are even, which are odd, and which are neither. Now make sure that you label each of the graphs as you draw them, so you know what the graph is when you go back and look at it. And use these tips that I gave in the video for even, odd, and neither to help you find these. You can also do it algebraically if you'd like. Good luck.